Hello friends, in my last video of Python series I was talking about this regular expression where I stated these following quantifiers. Now I don't know whether you could figure out from this particular program something that is very much relevant in Automata, which is called Non-Deterministic Finite Automata and Deterministic Finite Automata. I'm very sure those who are from computer science background, they have gone through these things in Automata, but how is it relevant with programs? That's what I will be exploring in this particular video. In my last video I said that if I take a single character, that means my input will be confined within this particular character only. Like over here I have to give a single character A, then only a match found will be true. And then we came across these three quantifiers. The first quantifier which I will be introducing once again is question mark. So let's consider this is what my regular expression is, a question mark. What do I mean by this? Well, there will be two valid input. One is I might not give any input, and that is called epsilon. So let's consider right now I'm in state Q0 with no input given. That means it's an epsilon transition. I move to Q1 and that is my final state. That means my program terminate over there, isn't it? So let me run the program. I give no input, I hit the enter, the program ends with a message called match found. So this is one valid input. Similarly, if I go and give one single A and I hit the enter, so imagine I'm in Q0 state with one single A, it will take me to Q1, which is my final state, and the program actually comes to an end and the match got found. So this is what called non-deterministic. Why? Because there is an epsilon move. So when you are in one particular state on a null input, you are making a transition. That's what called non-deterministic. You cannot determine. So we have to get rid of this non-deterministic approach. Okay, keep this thing in mind. Similarly, if I introduce the quantifier asterisk, the same thing is going to happen, but in this case, okay, one more thing. Since we are in question mark, if I try to give multiple input, that would not lead me to the final state, rather that will be a dead state. So if I try to run the program and if I give multiple A's right now, this is not a valid input and that will take me to the dead state, which is basically saying not match. Okay, so question mark will always take care about one single character, or else it can be epsilon also, but multiple character will lead to the dead state. Okay, so that's what the part of question mark is. Now moving to asterisk, this is also going to lead you to non-deterministic finite automata, because here also you can give epsilon as input. Let me run the code and let me give no input. This is also a valid input. So epsilon can be one valid input. So that means you are in state Q0. On the epsilon you move to Q1, which is a final state. So the double circle represent final state. Then the program comes to an end over there. What else can we do? We can give one single A also. That also will take me to the final state. So if I give one A, it's a valid input that takes me to the final state. Similarly, if I give multiple A's now, the first input takes me to the state Q1 and the rest of the other input will also continue to stay in the Q1 state, and that's the reason why this is also a valid match. So remember, in context to star and in context to question mark, these leads to non-deterministic finite automata because they are going to accept epsilon move. Now to get rid of this epsilon move, that brings us to something called plus. So let me replace the asterisk with plus sign. In this case you have to give a single character at least as input. So over here your expression is a plus, so your input has got no epsilon. You can give at least one, or you can go for as many you want. So if I give one single input, that is valid. If I give more than one single input, that is also valid. But if I give no input, that is not valid. So if I stay in Q0 with one input, I come to Q1. With multiple ones, it stay back in Q1. Those are all valid state. But if I give no input, that's invalid. That takes me to the dead state. So as you can see over here, plus is there. So if it is not going to have any input, that will take me to no match, which is basically the dead state. So this is what talks about in automata, non-deterministic finite automata or deterministic finite automata. In my upcoming videos, I will make the program in such a way so that you can relate with the theory of computer science, where regular expression was very much important. And these diagrams might not be that clear at that point of time, but definitely while you pursue these programs, definitely this diagram will be much more clear. And this was my the first program. I already made the second program, which I will be coming up in my next video. So stay tuned and keep watching. Bye bye.